Hello and welcome to discussion 5. So if you don't know, assignment 2 is due this coming Tuesday, March 2nd. There was a checkpoint quiz due, and we have 4 project parties in case you guys need help on these assignments. There's one Tuesday, Thursday, Friday, and Monday. The Tuesday one already passed, but feel free to go to any of the other ones if you need help with your project. Okay, ray triangle intersection. So in the past discussion, we talked about ray plane intersection, and the technique we're going to use to create this ray triangle intersection equation will be largely the same as what we did with our ray plane intersection. So let me go over this process a little bit, and then we'll try it for ray triangle intersection. So we have some ray equation that has an origin, a direction, and this parameter t that kind of denotes the time along this ray. And then we have our plane equation since we're doing our ray plane intersection. And in order to solve for intersection, we're going to set p equal to this ray equation and just solve for t. And that'll give us the time along the ray at which this ray intersects the plane. Okay, and we also have to check that this time is greater than 0 and less than infinity. If it's not, then that means that this ray does not intersect our plane. So let's try the same approach for ray triangle intersection. Let me just switch to my iPad. So let's solve for the intersection of a ray and a triangle. Specifically, if we arrange the unknowns t, b1, and b2 into a column vector, can you get a matrix M and a column vector B so that mx equals b? Okay, so let's follow the same process as before. So we have our equation for a triangle. We're going to use this one here since these are the same but rearranged. So we have p equals 1 minus b1 minus b2, p0 plus b1, p1 plus b2, p2. And you'll notice that these values here are actually our barycentric coordinates. Okay, so now we just need to set p equal to our ray equation. So actually, I'll just do that right here. Okay, and then now we just have to solve for t. So let's first think back to what form they're asking us to arrange this equation into. So in this one, it's a little bit different because we have our t that's unknown and our b1 and b2. So we kind of want to have these 3 parameters in some vector and everything else in either another vector or on this side of the equation. Okay, so let's just move some stuff around. So because t is an unknown, let's move it to the right. So we'll have O equals minus td plus 1 minus b1 minus b2, and then the rest of the equation. Okay, and now we also want to kind of separate all of these coefficients here. So how do we do that? Well, let's kind of combine. No, let's first expand this. Okay, so we'll have minus td So I'm just expanding this one part of the equation. Okay, and we're going to move this over since it doesn't have any unknowns. And for the rest of this, we're going to combine anything that has b1 multiplied by it. So minus b1, what has b1 would be p0 and p1. So that's these two here. And then we have b2, that's p0, p2. Okay. And now we can just write this in matrix form. So we have minus d. Let's just swap these here to make the math a little bit easier. So we'll do p1 minus p0, p2 minus p0, multiplied by t, b1, b2. Okay, and then that is the form that they were asking for in the original question. So this would be our M matrix here, and this is our B.